In a survey of 3,205 adults, 1,469 say they have started paying bills online in the last year. Construct a 99% confidence interval for the population proportion and interpret the results. Alright, the first part here is a 99% confidence interval for the proportion or population proportion is given, and we have two answer fields that we must put our answers in. This is key. Round to 3 decimal places is needed. In order to create a confidence interval, we need to use the following formula. And that's going to be given as p hat, which is our point estimate, minus the margin of error, less than p, which is our population proportion, less than p hat, plus the margin of error. Well, in order to find the margin of error, we're going to use the following formula. And that particular formula is going to be the critical z that we will obtain from the normal distribution table, multiplied by the square root of p hat, which is a point estimate for p, and q hat, which is a point estimate for q. Remember that p and q will be success and failure respectively, and that will be divided by n, which is the number of people in the sample. So first off, let's go ahead and define what p hat is going to be. And as I said, that is going to be our point estimate. And in order to find that, we're going to go ahead and take x and divide by n. Now what's x and what is n? Well, x is going to be our sample, the number of people in the sample. So this is x. And n will be the total number of people that were surveyed. And I said x is the sample. X will be the ones that have a positive or true outcome in this case. So this is a true. So now that we know what x and n are, we can go ahead and determine what that percentage or ratio is. So we'll take 1,469 and we will divide that by 3,205. And we just simply will put this into the calculator and we will get an answer. And that gives me a decimal of 0.4583. Now we need to find q hat, and that is simply going to be equal to 1 minus p hat, and that will be equal to 1 minus 0.4583, which will be equal to 0.5417. Now, I already know what n is. I know what x is. The last thing that I'm missing is z sub c. So z sub c, the critical value, is going to come straight out of the normal distribution table. And we will look at the critical value table, which is on the first page of your normal distribution. And we see that our level of confidence, C, is in this first column. And we're looking at a 0.99 level of confidence, which will give a z-score of 2.575. It's at this point that we can solve for E. So E, remember, is given by z sub c, which is 2.575, multiplied by the square root of p hat, which in this case is 0.4583 times Q hat, which in this case is 0.5417, and then that is divided by N, which is 3,205. Now you have to remember that this is basically going to be a plus or minus answer when I'm done in order to plug it into the confidence interval. But simply type this into the calculator and you will get the following answer. So E is given as 0.022663, and it continues. So we're going to round to 4 decimal places. Right here is the 4th decimal place, and this 6 will affect that, causing it to be a 7. So we end up with 0.0227. Now to create the confidence interval, we just plug in our numbers into the confidence interval itself. Remember that the confidence interval is given as p hat minus E less than P less than P hat plus E. And we know that P hat is 0.4583. And we will subtract from that the error interval, which is, or I should say the error value, which is 0.0227. And that will be less than P, which will in turn be less than P hat, which is once again 0.4583. And we will add the confidence, or I should say the level of error, to that value, which in this case is 0.0227. So doing the arithmetic, we will arrive at our confidence interval. So calculating these, we have a confidence interval of 0.4356 less than P less than 0.4810, and we can write that in interval notation just like this to indicate our upper and lower bounds. So now we need to interpret the results, and we're going to choose the correct answer below. Read the first statement. It says, with 99% confidence it can be said that the population proportion of adults who say they have started paying bills online in the last year is between the endpoints of the given confidence interval. And that would be the correct answer, because the key to this is population proportion. Because if we scroll back up and we look at the original problem, it says in a survey of 3,205 adults, 1,469 say they have started paying bills online in the last year. Construct a 99% confidence interval for the population proportion, and then interpret the results. So going back down to this, we see that population proportion is in this statement. And this would be the correct answer, because the next statement is virtually identical, except the difference is the sample proportion. And this is not a sample that we're studying. We're actually trying to extrapolate this back to the population. And then part C, the endpoints of the given confidence interval show that adults pay bills online 99% of the time. That is a false statement. We cannot make that statement.